Welcome back to All This Math. This is Professor Parker, and make sure you're subscribed to the All This Math YouTube channel. Make sure that you like this video, make sure you share this video, and if you want to, drop a comment down below. And this video was brought to you by the late Dr. Carter G. Woodson. I don't know if you can see the caption under his profile pic, but yeah, this is the late Dr. Carter G. Woodson, the creator of, well, at least I should say the first to recognize Negro History Week, right, back in 1926, which later became what we know as Black History Month. The author of several books, a great historian, wrote The Miseducation of the Negro, wrote The Education of the Negro, wrote many other historical texts as well. Definitely somebody you should check out. And looking at his work, you know what I'm saying? Yeah, just definitely check him out. One of my intellectual heroes. All right, now let's get into this. Now we are subtracting fractions right now. We're subtracting fractions. All right, we have 5/3, which is a little strange because usually the numerator is not larger than the denominator. When that happens, we call that an improper fraction. So you should write that down in your notes. Improper fraction. All right, 5/3 minus 3/4. All right, now add and subtract fractions, we must have what are called common denominators. Common denominators, meaning the denominators got to be the same. If they're not the same, you can't do it. All right? But that don't mean that when you see a problem like this, you say, oh, the denominator is not the same, can't do it, skip this one, go on to the next problem. No. You make the denominators the same by thinking about what number was the smallest number, even though it don't have to be the smallest, but if it's the smallest, that's the best thing for you because that's going to make the work easier. What's the smallest number that 3 and 4 can both multiply into? Can both multiply into. Meaning, 3 times 2 is 6. Can 4 multiply into 6 also? No, it can't. Not evenly. Not without a remainder. Right? You're talking about no remainders. Right? Multiples. In order to understand this, you should know the difference between a multiple and a factor. A multiple and a factor. A lot of people are confused between multiples and factors. Multiples are the number that you end up with when you multiply two factors. So for example, 3 and 2 are factors when you do 3 times 2, which equals 6. 6 would be the multiple. 3 and 2 are the factors, 6 would be the multiple. All right? So in this case, somebody will look at this and say, well, the common factor, the common multiple between 3 and 4, right? Because a common denominator is just a common multiple. You should write that down in your notes. A common denominator is just a common multiple. That's what a common denominator is. It's only called a denominator because we're dealing with two fractions. All right? So a common denominator is a common multiple, right? It's not a factor. Somebody might look at this and say, oh, well, 1 is the common multiple. 1 is not. You can't multiply by 3. You can't multiply 3 by any whole number and get a multiple of 1. You can divide 3 by a number and get 1 by itself. But that's not what we're trying to do. We're trying to multiply 3 by something to get a multiple. We're trying to multiply 4 by something to get a multiple. Sometimes, to find a common denominator, all you need to do is multiply the two denominators by each other. Multiply the uncommon denominators by each other. In this particular problem, doing that is cool because that's going to give you the LCD. But sometimes, and in some problems, and this is why you need to have number sense, this is why you need to know a little bit about numbers, you need to have practice with numbers. Sometimes multiplying the denominators together will give you a number that's big for no reason. That's just going to make the math more complicated because you're dealing with a bigger number than you have to, right? So, but in this particular case, if we do 3 times 4, we get 12. 12 is our common denominator. 12 is the smallest number that 3 can multiply into evenly and 4 can also multiply into evenly. 12 is a common denominator. So what we're going to do is we're going to write two fractions, equivalent fractions, a fraction that's equivalent to 5/3 and a fraction that's equivalent to 3/4 that have denominators of 12. That have denominators of 12. That's what we're about to do. All right, this is how we add or subtract fractions. If we were trying to multiply fractions, we wouldn't have to do all that. We could if we wanted to, but it wouldn't really be necessary, right? If we was dividing fractions, we wouldn't have to do all that. We could if we wanted to, but it's not a requirement. You know what I'm saying? It's not a requirement. All right, so, but before we even do that, I want you to think about what these fractions represent. What does 5/3 even mean for real? right? What 5/3 means is you have an object that's cut into three equal parts, and you are focused on five of those. It's all about focus. Math is all about focus. You're watching this in class. I hope that you focus, because if you're not focused, you probably won't understand this, right? Unless you already know it. All right. But think about what I just said. You have an object that's cut up or divided up into three equal parts. Heavy on the word equal, right? Three equal parts, but you got five of them. How you gonna focus or have five of them if you only got three altogether? That's what makes this fraction improper. It's a weird situation. It's a very weird situation. We gotta think about it though. What's gonna happen is when your numerator is bigger than your denominator, that means you have more than one object you're dealing with. So we got one object that's cut up into three equal pieces. So we're focused on all three of those pieces. Then in order to have room for two more pieces, since 3 plus 2 is 5, you need a whole other object. So now you, in this situation, you would have two objects. Two objects that both cut up into three equal pieces. And in the first object, you're focused on all three of those pieces. In the second object, you only focused on two of them, because 3 plus 2 is 5. 3 plus 2 is 5. So two objects. Sometimes when you got an improper fraction, you might have three objects, or four objects, or five objects, or six, or seven, or whatever, right? It depends on the situation. So you got two objects. They're each cut up into three equal pieces. And in the first object, all three pieces are accounted for or focused on. In the second object, two pieces are accounted for and focused on. All right? That's what's going to happen. Now here, 3/4. What does 3/4 mean? 3/4 means you got an object. It's divided up into four equal pieces because your denominator is 4. It's denominated or divided into four equal pieces. And then out of those four equal pieces, you are focused on three of them. You're focused on three of them. All right? So now we already talked about what the LCD should be, or the least common denominator. We already talked about all that, right? So let's do our equivalent fractions. So we got 12, and then we got 12, and check this out, right? This 3 turned into a 12. So that means this 5 got to turn into something. This 4 turned into a 12. So that means this 3 got to turn into something, right? So if 3 turned into a 12, how did that happen? By multiplication. But by what number? 3 times what equals 12? 3 times 4 equals 12. And to do this, let me say this too. You need to know your multiplication facts. If you don't know your multiplication facts, you're going to be down bad. It's going to get ugly. And these problems that should be relatively easy, they should be, if you know how to do them. If somebody teach you how to do them, they're easy. If don't nobody teach you how to do them, they're not going to be easy, right? But you need to know your multiplication facts so you can get down with these, all right? So we say 3 times 4 gives us 12. As it is below, so it is above. As it is below, so it is above. What does that mean? That means if I multiply by 4 in the denominator, I need to multiply by 4 with the numerator. Whatever I do on the bottom, I do on the top. Whatever I do on the bottom, I do on the top. You take a shower, you wash your leg. You take a shower, you wash your arm. Same thing. You wash your legs, you wash your arm. What you do on the bottom, you do up top. Same concept. All right, so we do 5 times 4. Know your multiplication facts. That's going to be 20. Over here, how does this 4 turn into a 12? Multiply by 3 or triple it. Triple it or multiply by 3. What you do on the bottom, you do on the top. What you do on the bottom, you do on the top. 3 times 3 is 9. Now we're ready to subtract, because you can't subtract quarters from thirds. You can't subtract quarters from thirds, but you can subtract twelfths from twelfths because we have a common denomination. We got a common denomination. You can subtract twelfths from twelfths. That's what you can do. All right. Now, how many twelfths do we have here? In the first fraction, we have 20 of them. How many twelfths do we have here in the second fraction? We have 9 of them. So we do 20 minus 9. 20 minus 9 is 11. That's how many twelfths we have left. That's the difference. 11 twelfths. Now I'm going to draw a box around this because this is the final answer. And how do I know it's the final answer? Whenever we're dealing with fractions, always think about this. Can I reduce this fraction? Can I simplify this fraction? This you cannot. How do I know that though? And how should you know that? You should know that because the common factor between the numerator and the denominator is a 1. Whenever you are one and done, that means you can't reduce it anymore. So if your common factor, this is a question you should always ask yourself whenever you do any problems dealing with fractions. If your common factor between your numerator and your denominator is a positive 1, then you can't do nothing with it. You're done. That's the final answer. This is 11/12. That's the final answer. All right, 11/12. Now, go get some practice with subtracting fractions with unlike denominators. Another shout out to Dr. Carter G. Woodson. Go do your research on him, and I'll see y'all in the next video. I'm out.